No. It
Record
started
already.
already.
I
Okay.
record already. Yeah.
Yeah. Okay. So what we are going to do today is talk about the modularization. Okay. So I think I just go to touch some of the practice. Then later I will talk a little bit on what is the theory behind. Okay. So let's consider this case. I mean, this is the hello world examples we had at the first tutorials. Okay, so now, yeah, I think this is not straightforward. Let's use this one. Okay, use this one. Okay, let's use this one. So consider that now we have a world. Okay, then we have this cloud. Maybe you consider this as a space. I mean, somewhere in the universe. Yeah, we don't know what is really happened. Okay, then what we know is that whenever something happens, then we have this hello world event, then this world will change something, okay, by adding the population by 1, for example. Okay, so now is that in the previous way of doing the simulation, we put both of these two things, okay, into one sandbox, okay. But now it's something is that we want to do kind of a separation, okay, in the sense that we want to model this space as one part, okay, we want to model this world another part. Why? It's because this hello world event, okay, in this case, is actually triggered by something happening in the space, okay, so we represent by the space, the cloud. We don't know what is happening, but this event can also be uh, triggered. Okay, it's also happening because of some other reason we don't know. Okay, but now we just want to indicate the logic is that okay, whenever there's something happens, okay, this word should observe and it will trigger some change in the word. We do not really care that who is actually the one trigger these things. And also for the cloud, okay, for this like space, you also have the similar consideration. You see that, okay, I just want to simulate the scenario that every 5 minutes something happen. I don't really care about the consequence. Okay, so whoever like observe this and want to do something, you just do whatever you want. Okay, but we just want to simulate this logic of what is happening inside the space. Okay, so this actually quite similar. Okay, when we want to model some complex system. Okay, so instead of model everything's into one thing, okay, so now we want to like separate them into the different parts. So the similar concept, you can refer to this one at the sandbox. I think I showed you last time, is when we building our simulation model, so we actually are creating some things in this sandbox. But now is that instead of the single sandbox, right, we're actually making the multiple sandbox. Then we create a certain protocol to let the sandbox to affect each other. Then you can see that within the sandbox, okay, we just care about what is happening inside. But now is that we also care about this interface that whoever is like a trigger or bring a change through this interface. But we do not care that who is the one make this triggering this change through this interface. Okay, so within this sandbox, we do not need to know there is another sandbox outside. So I think this is the basic idea of doing the modularization, and I hope you understood that this is actually a way that we start to model those complex system, and by digest and decompose them into the different part. Okay, so let's take this example and go into the C# code and to see that how do we separate this logic, okay, using the O2DES.NET. Okay, so I think I will start another project. Okay, so I will create another project here. Okay, still we use the .NET Core, the console application. Okay, we give a name. Maybe you see the O2DES modular. Okay, you can give any name of it. Okay, then still follow the same procedure. We go to tools, NuGet package. Okay, then we search for O2DES.NET. Okay, then we install this ones into our project. Okay, so now we have prepared, okay, the development environment. So what we're going to do is now we want to create a two sandbox. One is in charge of generating the event. The other one is actually in terms of observing this event and make some state update. Okay, so now let's create a 2-1. The first one, maybe we can call this as generator. Yes. Okay, then the second one, we call it the world. Second one, we call it the world. Okay, so both of these things, we let them to extend the O2DES net dot sandbox. Okay, so I think as I explained to you last time, it's actually this one we can remove. Then we put it here, the namespace. We indicate the namespace here. Okay, O2DES net. So here we can extend the sandbox directly. Then the similar things, maybe you can do this later lah. Okay, for the world. Okay. So if we do it this way, okay, so we still like follow what we, yeah, maybe let's do it this way lah. We remember what we had last time, the first time when we come up with this hello world example. So what are we doing at the beginning? What we did last time, okay, at the beginning, do you still remember in the hello world example? The most important thing is what? It's the events, right? So we need to define the events. Maybe now we just ignored about the static, dynamic properties. We put it later. Okay, so let's focus on the event first. So what we are going to do here is, yeah, we just follow the same way we create an event called Arrive. Okay, let's create this Arrive event. So what this Arrive events will do is that, okay, we print a message, okay, print a message to let the user know, okay, the player know that there is actually something happening in the space, okay. So we'll see that arrived, okay. Then we put a clock time here. Sorry. Put a clock time here. Then what we are going to do is we need to schedule the next arrive event. We need to schedule the next arrive events in 5 minutes. Okay. So now let's assume it's a constant time because I think last time you already know how to do the random time. So now let's make it simple. So we still use the constant time. Okay, so this is actually a generator. So what do we need to do after this? Do you still remember? Is we need to come up with the constructor. Why we need a constructor is because we need to schedule the first arrive event. Then the arrive event will trigger the next one after the 5 minutes, right? So this is what we are going to do. We need to schedule the first arrive events at the current time. So that is followed by nothing. Okay, so if we go to the program, okay, so if we go to the program, we will see that, okay, we can actually create a simulator by using this generator, okay, by using this generator. Yeah, to construct the toy, okay, then we let this toy to run for maybe 1 hour time. So I think these steps are exactly the same as the last time, but later we'll show you where is a part that it makes a change. Okay. Then we can see what's happening here. Okay, I think what can be expected, right, is will generate, if I'm not wrong, 12 or maybe 13, including the first one and the last one. Okay, events, right? So every 5 minutes, we'll see this arrived. Okay, so this is actually exactly what we did last time at the very beginning. So now is that we want to see that, okay, when this arrive is happening, we do not actually change any like dynamic properties, update any information, but rather we want this world, okay, to to capture that it's actually arrived. So probably I think a more precise way is to say this is not the arrive, but actually generate. Yeah, because from a generate point of view, this event should call a generate. So here is actually generated, but actually it's the other at the world. Okay, when we look at this event, it's actually arrive. Okay, it was generated from the space, then we go to a world, then it's called an arrive. Okay, so what we are going to do here is we need to have this event we call arrive. Okay, so in this arrive, we're actually doing the similar things. Okay, we just print out the message. Okay, let me see this arrived. Okay, sorry, I forgot one thing. So this one need to extend the sandbox. Yeah, this one need to extend the sandbox. Then we just need to create this print out this message called arrive. Do we need to schedule the next arrive? No. Yeah, it's because this world is supposed to receive something, observe something from the outside, and response to it. Okay, by doing something. Okay, so what we are going to do is probably we can adding a one dynamic property called account. Okay, so what this account will do is that it will basically look into how many have arrived. Okay, so in this arrive event, what we are going to do is we'll let this account +1. Okay, then we'll here we'll see that okay when we observe one arrive event, then we'll see that this account actually equals to something. I will print out these values here. Okay, so this is what the world okay is doing. So if you look at this one, you can see that here this is a generator. We're using this mechanism every 5 minutes, generate one event. Okay, but it will do nothing. Okay, to update the no property will be updated here, but rather the properties will be recorded in another sandbox. Okay, which is called the world. Okay, so now you can see that in the world, actually, you may ask a question why there's a no constructor. Yeah, because there's a nothing we really want to initialize here. Yeah, because the count already set initial value here, and we are not supposed to have the initial arrive events, right? So this event it actually should be depends on the outside. I mean, this will actually be we call this as an input event. I mean, it will be affected by what is happening outside this module of this sandbox. So that's why we should not schedule any events. Okay, at the beginning when this sandbox is calculated. Okay, is constructed. Okay, it's constructed. Okay, so now we actually have this two modules. Okay, so now the problem comes is how do we connect them together? How do we connect them together? So let's go into this one. Okay, so if you consider that this one as one module and this one as another module, okay, then the way to connect them together is through the output and input event interface. Okay, so what does this mean? I think maybe later I should draw a diagram. But here, just imagine this as a module represented by one rectangle. This is another rectangle. So for this rectangle, it should have output events. Okay, meaning output event meaning that something happens inside this module which will affect the change of the status. Okay, of the external party. Okay, so that's why whenever this arrive, it should have an arrow point out. Okay, so this arrow will call the output event. Then correspondingly for this world, okay, this model, it should have an error like a point into the module, so which we call input event. So this meaning that something happening outside will affect the state change of this module. So it will be something that point in. So let me show you that what is actually, how do we model this point out and this point in. Okay, let's talk about a point out. Whenever there's something happen called a generate, okay, when this event generate, so we should let the outside to notice, okay, there's something happening, okay. But if you remember these things, okay, this voice when there's a nothing in front, so what does this mean? It means that this is actually a internal events, or maybe in the C# we call this a private method. Okay, private method actually corresponding to internal events, meaning something happening only inside this generator, so that the outside cannot see it. Okay, cannot see. So in order to make this link to the outside, so what we are going to do is that we use the event delegate, okay, of this C#. So how do we write this one is actually the event. Yeah. Need to record a little bit. Okay, event. Then yeah, sorry. Let me think about it. So it's an action. Okay, on generate. Lisa, I think I didn't touch the O2DES for some time, so I need to. Yeah, probably I need to refer to my previous training materials. Rita, can you help me?
This one just put a semicolon.
Semicolon. I think I need
Yeah.
to. I need to.
And then on if
I need
there's
initialize. I need to initialize the value, right?
uh you can initialize in the constructor if you want, or you can initialize yeah, or you can just on generate question mark and then send the message out, invoke.
Let me see. Wait.
This one is already available outside. All you have to do just invoke.
Sorry. Let me get my previous.
You can use a equal and then a bracket. Uh,
Yes.
equal
I'm sending.
no with yeah,
Right,
correct.
right. Sorry. Yeah, I need to prepare for this. Okay, so yeah, so you see that this actually we define this as an interface to connect to anything happening outside. Okay, connect to like the yeah, something happening outside, and this one we actually you can imagine this one as a socket. Okay, it's like when you have this like a point. So this is actually a socket. So this a socket. We define this a socket here. So later that you can actually plug in any of the plug, okay, into that. So whenever there's a signal in this socket, then all the plug which are plugging to this socket will know that there's something happening. Okay, and also you see this one actually a very like a familiar kind of the notations. Okay, this is a syntax you may encounter at the time you schedule internal events. Okay, so if you still remember last time when we have these things, okay, so still remember this syntax, right? So actually it's a similar. So what does this mean? What does this uh, expression mean is that it's actually define the format of this socket. So for example, in the point, okay, at your home, you will see that actually there's a different type of socket. Sometimes you have a 2-pin, sometimes you have a 3-pin, right? So I think it's a common sense that you cannot plug in a 3-pin plug into a 2-pin socket. It's actually the same principle that follows here. Okay, so when you define these things, you need to make sure that when whichever like method or events you plug in need to have the same format. Okay, so this is a format meaning that there is no parameter. Okay, in this case, there is a no parameter. So that this a bracket inside is actually empty, nothing. Okay, then if you want to say that what happened if I want this a socket to passing an integer. Okay, so in that case, what we should do is we need to define in this way, meaning that this action, okay, is about the integer. There will be integer passing, and here we need to say that this integer will be, for example, I. Okay, then we actually process some things with I. Okay, so this I will be an integer lah. Okay, so here I think for the simplest case, we actually define this socket as is nothing. Okay, the format of this socket is nothing. So now when this socket is defined, so you need to see that this socket is unconnected, disconnected to the other part of this sandbox. Okay, it's not connected to any internal part of this sandbox. So what we are going to do is we need to connect the internal logic to this socket. How do we do that? The generate. So what does this mean? It means that whenever this generate event happen, then it should inform the outside through this socket to say that there's something happening. So that's why in this generate event, we need to do these things. Okay, is to see that this OnGenerate event we want to invoke. Okay, we want to invoke this event delegate. Okay, the basically is to say that I will send the signal to this socket. So whichever connected to this socket will receive this information. Okay, so this is actually the basic ideas. Okay, so in that case, actually we have completed this socket and connected to the internal logic. Then we actually complete this module, the generator. So what we are going to do is that we need to move to the other one. Okay, you can treat this as a applicant, okay, who which you need to like plug in into this socket. Okay, so what we are going to do here is we need to define this plug. Okay, which actually the input events. We need to define these input events. So this practice is actually very simple. It's much simpler than the last time. And basically, we just expose this internal event to the public by adding this thing. Okay. Then we can see that this will actually transfer from an internal event to a public event, so which can be used as an input event. Okay, so this will actually become a public from like a plug, which you can plug in into the socket. So what we are going to do here is to see that I will show to you. Okay, so what we are going to do here is whenever we will have a generator and when we have a world object. So whenever we have this two sandbox, okay, this is sandbox. So what we can do is that we need to we can connect this OnGenerate events of this generator to the world.Arrive. Okay, so this syntax is an expression basically meaning that I'm actually plugging this plug into this socket. Why these two can be connected together is because that this arrive, okay, has no parameter. Actually, you see this is a format. This is a format signature of this method is that they have no parameter passing and no parameter pass out because it's actually we define this as an event, so it should not have any like returning type. So the parameter is empty. Then the same thing happens here. When you see this apply, it's also there's a nothing passing and nothing go out. Okay, so you have the same format. So that's why here you can plug them together. But just in case that we change one of them, for example, if we have this arrive event to have an integer, for example, I, then you can see that here we cannot do so because the format is not consistent, meaning that you're actually trying to plug a 2-pin plug into a 3-pin socket. So it's not possible, right? So yeah, so let's remove this thing first. Okay, but you can see that whether we can just directly go into this one and run the simulation. It's possible, but yeah,
Yeah,
someone
it's
want to ask a
possible.
question? Yeah.
Yeah. So actually, you can use the plus equal sign. You can replace with equal and then greater than and the arrow shape, and then using a comma, sorry, bracket as you, yes, and then bracket. No, no, I mean bracket equals bracket. Yeah,
Uh,
yeah, and then
uh,
yes, it's not working. Okay, later lah.
okay. No. This is it because this is actually event. We define this as
Yeah,
an
yeah.
event.
Okay.
Yeah, okay. Event is that it cannot be replaced
Yeah,
a
I
value
forgot.
lah.
This one is an
Yeah,
event. Yeah.
yeah. This is event. So can only yeah. Actually, this is the same. I mean,
Yeah.
as
If
I
you
mentioned last time.
pass, if you want to pass the integer, you pass like that. You
Yeah,
put
yeah,
I
yeah.
and then you, yeah.
Right, correct. I think this is too deep now. Let's do it step
Okay,
by
okay.
step.
Okay, I
Okay,
just keep
let's
quiet.
just remember this. Just let's remember this. Yeah. So yeah, it's possible to let the program run, but it may not deliver what you really want to observe from the simulation. Why? It's because this space and the world have a different clock time. Okay, so if you do in this way, this new generator will have a clock time. If you do a new world, this world will have another clock time. So it's possible that when you connect together, you let the generator to run, then the generator's clock will start clocking and start ticking. Then when they generate event, when it's a trigger event for the world, the clock time of the world does not change. Okay, so this will be a summer problem. This will become a sum problem. That means the two clocks are not synchronized together. So how do we solve this problem? We need to come up with a system and put these two things under the parent system. We need to create a larger environment. Okay, then we put both of these two things under this larger environment so that the clock time can synchronize with the parent. Okay, so how do we do that? Let me show you. So instead of this two module only, we need to create another module called a system. Okay. Maybe I call this as a system. Sometimes it can be used as a keyword. So better I change it to another. Maybe I call the parent or maybe root or what. Let's call the parent. Okay. So what we are going to do is, the same thing. The parent will be another sandbox. So the basic idea is that now we have a small sandbox. Okay, so now I want to make the communication between this sandbox safe because there's some things out of the control of the sandbox, right? So which we do not want to see. So the approach is that I create a larger sandbox to put this two sandbox inside it. Okay, so everything is protected. Everything is able to be migrate to another environment without affecting the external things, and also we can make a clock. Okay, in this a bigger sandbox to let each of the small sandbox to conform to. Okay, to synchronize with. So this is actually the logic. So that's why we have this parent module. Okay, which is also a sandbox. So what is inside this module is exactly what we have here in this program. Okay, we need to have a generator, we need to have the world. Okay, by now is when we define under this let's just copy it here to this parent. Okay, but we need to define this one as a properties of this parent module. Okay, so what should we do is we should see that, okay, now we have a generator and the type is a generator, then the name is generator as well. Okay, so it will become a submodule of the parent. Okay, then we can remove this one. Maybe later we do this in the constructor. And similarly, we'll have another thing called a world. Okay, this world will also be the submodule of this parent sandbox. Okay. Then after that, what we are going to do is we need to construct this parent by making these things inside. Okay. So what we are going to do is we need to have a generator equals to new generator. This world equals to new world. Okay. Then we let the generator on generate. Okay, we need to plug in this arrive event to the generator output events. But there we will have a common mistake. So if you're doing this one, it meaning that although it's defined as a sub property here, but the parent does not really know that these are the trials of this property of this sandbox. It's just treated as any other like a common properties of this toy, meaning that you do not really like connect all the clock or whatever you need to like synchronize to the parent. So in order to make it as a child and the parent relationship, we need to do in this way. We need to add child of these subcomponents. Yeah. So in this way, okay. So in this way, we actually have built this parent and a child relationship. So whoever which is happening here, okay, the parents, I mean the clock ticking will be affected by the in the child. Okay, so this is the things, okay, we need to do, so that now it's connected and it's put under the parent, so the model should be able to run. Let's see, we go to the program. So instead of using the generator, what we are going to have is actually the parent. Then we run the parent for 1 hour. Let's see what is happening. Okay, so you can see clearly that instead of the 13 events of the generator only, so now we also have the events which at the world, okay, whenever it's a generated, one event generated, okay, then it's got arrived, then we can see that this account increased by 1. And also we can see that the clock time is synchronized, okay, when this is happening, then exactly at the same clock time, this event is actually affect the state of the world component. You can see that the clock time actually are the same, okay. So this is actually exactly what we are going to do and demo to you, okay, by this example. Okay. By now, any questions? Okay. Any questions? If no, let's just touch a little bit more on the random stream. Okay. So I think you remember last time is the generator in a queue, or in the, like, even in the first tutorial, we have mentioned that this is a generator when we have this interval time. The time can be stochastic. Okay, for example, let's assume it's exponential distributed. So what we are going to do is that, okay, we need to, instead of just like a constant of 5 minutes, we need to use exponential distribution, okay, to sample time with 5 minutes as a mean, as expected value. Then we also need to control these things by code a random stream, which is a default RS. Okay, we need to code this a random stream. What is happening here?
I think you use the met.
Yeah,
Yeah.
right. So this one, we should change to using O2DES net dot distribution. Yeah, so that we can set a mean as a time span. Okay, so and also in order to affect this default random stream, so what we are going to do is that here we need to extend the base constructor, okay, by code the seed value, which the seed will be passing as a 1 parameter for the generator. Okay, so in that case, if you change the seed value, then we can see that, okay, this random stream got changed. But here we actually got one problem. The problem is that we can see that this random stream is a random stream of the generator, right? So it's probably that if there's something randomly happening in the world should also have another random stream, right? Then we see that if we put the two of these things under the parent, this a parent as a separate sandbox should also have another random stream. So in that case, that yeah, so here is clearly that each sandbox, when they play with the dice, okay, it's only play with the random stream under that sandbox. But how do we allocate the random seed for all the different subcomponents in a complex system? So this has become a problem. Whether we should do this one by one. For example, if a pod will have maybe 100 equipments, and each equipment involves certain randomness. So whether we should, when we construct this the whole terminal object, whether we should give the 100 random seed to give to each of the module, the equipment. I think in that case will be too tedious. Possibly it's not a good solution. Okay, so the way we do that is that we're actually using the parent, the random stream of the parent, to generate the random seed for the child. Okay, so we use this one as a practice. let's say just now we have a generator. We said we make it a randomized, right? So the generator should the constructor should follow by a seed, right? So the way we put it into this seed is that we use the random stream of the parent to generate an integer and make this integer as a random seed of the generator. And in order to control this random stream, then we do the same thing here by passing this seed, okay, inside the parent constructor. So here you can see that when this seed is changed, then this default stream will be changed. When this default stream will be changed, then the random seed of the generator will be changed. Okay, so meaning that this changing of the random stream will be inductive, okay, and affected all the children components under the root, under the parent. Okay, then just imagine that this word also got some randomness, so that's why we have these things inside. Then you can see that the random set of the words will also be changed, but also because that we're using a random stream to generate this two seed respectively, then we can see that, okay, this random seed will be different for this two component. But now it's because we don't have a randomness inside implemented for the world, so we don't care about that. Okay, so this is actually how do we define the random seed and make it inductive, okay, to all the children. Okay, then in this case, when you place this module, you will see that, okay, the time got the difference, it will become a different 0, this is 47 seconds. Then you can see that if we want to change the random seed here from 0 to 1, so you can see that, okay, the generator, the random seed of the generator also changed. So that's why you observe a different time here. But you see that this time is not directly because the root, that the parent random stream changed, but it's because the change of the random stream in the parent affect the change of the random stream of the generator. Then because of the different random stream of the generator, the different time is generated. Okay, so this is actually the reason. Okay, so by now, do you have any questions on this? Okay, if no, I will continue with the next step is that we need to see that how can we digest, how can we like decompose the simple, the queuing model, the MMC model, okay, using this modular concept. Okay, so let's go to this one. So this is actually the queuing model we have. I think better not to look into the event diagram because I think it's actually a little bit troublesome or confusing by using the event diagram to tell us how to do the composition. Okay, later I will explain the reason. Rather, it's good to look into this one. Okay, to look into this kind of the graph. Okay, the conceptual model. Okay, to see that how to do the decomposition. So basically, it's as simple as this. The claw is a like a generator, and this is a queue. This is a server. So naturally, we can think that okay, let's cut in this way. Okay, we cut we do one cut here and one cut here. So you can see that the generator will be one. So actually we already got, okay, just use the same one. Then the queue will be another one. Then this machine, the server will be the third component. So because this is a generator we already have, so now we need to think about how to do the model for the queue and for the server. Okay. So how do we consider that? Okay, so how do we consider this a problem? So in this case, we need to touch a little bit into the theory. So what is the theory behind to guide us for the modularization? So modularization actually another name, I mean a technical term, or maybe the, I don't know what is the best name, scientific name, okay, for this approach is actually called state-based discrete event simulation. Okay, so the so-called state-based is meaning that we are actually model it based on the state variable. Okay, so Do you still remember the last time when we were talking about um, the queuing model? We actually mentioned about what are the state variables we are observing here. Do you still remember what are state variable?
Yes, yes.
Someone can answer me. Yeah, actually, it's indicated here. Yeah, someone can answer. Hello, anyone can give me the answer? Shinju, do you want to try?
Is this a queue number?
The queue number, yes. The queue
The
length, right?
yeah,
Yeah, the other one.
and the capacity.
The actually not capacity, state. Okay.
Oh,
So it will be a number in service, right? I
yes,
mean the state of the machine, whether it's a busy, but if it's more than one, it's a number in service, right?
yeah, correct.
Okay, so we actually got this two state variable. Then you can see that the way we cut it is actually cut based on the state variable, right? So we cut this as a queue is because this actually the part contains one state variable called the queue length. This one is actually cut. It's because it contain a, a state variable called a number in service, right? So we can see that if we want to look into events, events is actually something usually across different modules, but it will be naturally, if we look into the state variable, it will be very clear to see that how can we do the modularization. So basically we can say in this way, it's the state variable can only belongs to one module, okay? So by looking at how many state variable, by thinking about how to classify, categorize, those I mean group the different like a state variable, you actually have a very clear idea that how to do the modularization. For example, if you like put, you can actually put in this Q and M together as one module, so you can actually separate this one and this one. You can also like separate this one further into two. Okay, so this will be the idea. Then when this idea is clear, we know that, okay, now we need to have a queue module, we need to have a server module. The next question we should ask is, you just focus on the queue module. Ask a question, what are the events which will affect the change of this queue module, the queue variable? What will be the things happening which affect the change, will bring a change of this queue?
Arrive and start.
Arrive, right?
And
Arrive, then the queue will plus one. Then if it does a start, okay, then the queue will increase will uh be reduced by one, right?
yes.
Yes, okay, exactly. So these are the two events will bring a change of this queue value. So that's why these two events will become the input events, will become the input events, okay, of the queue. So how about the M? Okay, the number in machine, the number in service. What will bring a change to, I mean, from, yeah, let's answer this a question first. What events will bring a change to this M value?
So, sir, when we start, then it will increase from
Yes,
increase
yes,
M and decrease Q.
yes. And let's talk about the M. We don't talk about Q. Q already mentioned. Now using
Okay,
a
sir.
modular concept is first we do the cutting. After we do the cut, we focus on the state variable first. A state
Okay, sir.
variable. Okay, so now we forget about Q. We just talk about the M. So M, yes, you are right. The start event will bring a change to M, right? It will increase M
Yes.
by one. How about the other? How about the other events will affect the will bring a change to this M value?
And
What
service.
the end service, right? The end service, yes. So start and end are the two events which will affect the changing of the M, right? So these are the two events. So now the next question we are going to ask is, which one is external, which one is internal? Okay, let's go to the queue first. For the queue, arrive and start, just now we mentioned about this one. Which are external, which are internal?
Sir, i- uh, internal will be when the event arrives. External will be when it is generated.
Mm, yeah, let's see. Mm, again, so internal will be arrive, right? Whether arrive will be internal or external?
Sir, internal.
Why?
Sir, because it
There's
is
something the queue can
no, no,
can
no,
can.
no, 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 sir. Start will be internal, arrive will be external
Okay, the first answer
because
is
we can see.
okay. Let's say the arrive will be internal or external. Let's answer the question one by one. Arrive will
Okay.
it be internal or external?
Sir, do we have generate?
Yes, a generator will be something outside.
Yeah, so that will be external. Then
It will be external for the queue, right?
yeah,
Yeah. So if the generator will have something outside, then arrive will be external for the queue.
internal.
Right? Well,
That
sorry.
it will be, sir. It will be internal or external?
No, when generator is separated,
Yeah,
okay, then the arrive will become an external, right?
yeah. Okay, okay.
Yeah,
Yes,
right.
yes.
When generator is outside, then arrive become a external, right? Then also consider that Q and M are separate things, whether start will be internal or external.
It will be external.
It will be external, right? Yeah, because
Yeah,
the
they are
start
separate.
is something Q individual cannot control, right?
Mm-hmm. Right.
Okay, so both arrive and start will be external for Q. How about
Yeah,
the M? How about the M? You have this start and the end. So which one is external? Which one is internal?
sir. Both will be external.
Okay, so let's say a start will be
I think
external,
and
right?
is internal.
Okay, so let's do it one by one. Start will be external. Why? Is because you cannot start with nothing. Okay, you need to at
Yeah.
least to make sure that some conditions outside, then this machine can start, right? So start will be trigger from external, right? But how about
Yeah.
the end?
Okay, that will be internal.
Yeah, end will be internal. So
Okay,
as
okay.
long
Now
as the
understood.
start
Yeah.
is a trigger, then in
Yeah.
end is actually something the internally will be scheduled, right?
So, sir, can I ask you one more question?
Yes, yes.
So, if we go back to queue, to the buffer, then if suppose we have the generator
Hmm.
generate, uh, then arrive will be internal because we have something inside.
You have
Correct? No.
some you have something inside where?
It's already lined up in the generator. No, it is generating randomly. So
Yeah, I mean generating is something's outside.
outside.
So arrive is something depends on generator, right?
Yeah.
Yeah, so it will be considered as external lah. It will be considered
Okay.
as external. Okay? Yeah, actually
Okay.
depends on the outside. I mean the Q is just a state variable. It's just a state variable, and whichever is actually whichever method or events which are affect the changing of this variable, okay, then the way to check whether it's external or internal is to say that whether it's directly triggered by outside. Okay, or maybe we should say that whether it's involve any the triggering from the outside. Okay, why do we say this? Because for example, arrive is purely based on the outside, right? So when there's something from outside, then it's called arrive. Okay, outside of the queue. And also, but for the machine, it's like when it start, actually start based on two conditions. The first one is that something's outside. Okay, another thing is actually the internal issue have some like uh, it should have some of the some like vacancy. So that's why this start is something's involved the calling from the outside. Okay, so this is how we define as the external event. Then the internal event is that it will be triggered internally. Okay, internally meaning that it will be triggered from another event, but this another event can be both internal or external lah. Okay, but as long as the scheduling of this events is handled internally, then this is actually internal event. Okay, so this is what N is. Okay, so I hope this explanation is clear. Okay, so let's recall what we did just now. Okay, so here is actually we are trying to conceptualize the modularization by doing things in this by applying this state-based discrete event simulation modeling. Okay, so the way we do that is that we look into the state variable. Okay, then based on the state variable, we basically do some like a grouping. Okay, then we actually identify how many modules we should have. Okay, so this is actually the first step. The second step is that so here the second step actually is a no right and wrong. For example, now we have a Q and M. You can put this as a one module. You can also separate as a two module. So there's a no right and wrong. Just need to do a proper grouping. Okay, you just need to do a proper grouping. So this is more an art. Okay, of how to do the grouping and the modularization. So now we decide to separate and Q and M. Okay, then we move to the next step is to see that for each state variable or each group of a state variable. So what are the events that will bring a change of this state variable. So that's one we actually make them as the events which are attached together with this state variable. Okay, this is a second step. So we identify for Q we have arrive and start. For the M we have a start and end. Okay, so this is a second step. The third step, is that for each of these events uh, of the uh, of the module, we need to identify which one is actually input. No, sorry, which one is actually the external, which one are actually internal. So how to do this is to say that whether it's a trigger by the outside from the outside or it's a trigger by some of the internal mechanism. Okay, so this will be the third step. Okay, so by going through this third step, so we actually come up with proper like a conceptual model with a modularization. Then later we can go to the C# to see that how do we implement it. But now I think because of the time limit, I don't want to do it in today's session. Maybe you can leave it to tomorrow. But what I want to let you to think about is how similar this approach, okay, by comparing this one with the object-oriented programming. Okay, you remember object-oriented programming. So what we will have is we have a properties attribute. We also have the method. So what we are going to do with the OOP is that we're trying to encapsulate the attribute properties with the methods, right? And for property and the method, we also have a private method, public method. Private method is something only can be accessible inside the object. Then the public one is actually some things we can access from the outside. So you can actually compare the the modularized discrete event simulation to the OOP to see that okay, now the state variable is something like attribute, like the properties of the OOP of the object. And the first one is the simulation module is compared to the object. Then the state of the module, okay, actually compared to the attribute, the properties of the class of the object. Okay, then the events of the simulation actually you can compare to the method, okay, of the object. Then similarly is here we got the internal events, external events. So in the OOP we have the private method and the public method. So you can see the relationship between these two concepts is actually one-to-one. And also later, if we were like implement it in the C#, it's actually, you can see that we are exactly using the same features of the OOP to represent what we define for the discrete event simulation module. So this is actually another strong reason why we call this O2DES, okay, object-oriented discrete event simulation. Okay, so any question on this? I think maybe in the later in the bigger group training, trying to make all those things into a slice, so it will be easier to see and understand. Okay, so any questions from you? Or Rita, you want to have something to add on? I
Yeah,
also want to. Yeah.
yeah. If you need help to, I can make the slide animate, so it's not showing like this directly. So yeah, maybe it can be more informative.
Yeah, I think I will try first. I don't want to waste
Yeah,
your time. I have
yeah.
a more important task for you to do.
Okay,
Yeah,
okay.
I will do this first, but later I will pass it to you and see that whether you can have any comments that how we can improve this.
Yeah,
Yeah,
yeah.
yeah.
So far, no lah. No comment.
Okay, okay. Thank you, thank you. So for the rest of the group, are you okay with this? So I think today what you uh, have learned is actually the modularization by looking into this hello world example by separate the generator and the status. Yeah, this word status variable, and also learn that how to define the module and assemble them together under the parents, and also how to like set this random stream and make a setting of the random seed inductive. So in that case, you only need to set a seed for the parent, and all the components seeds are set automatically. So I think this is something later I will share this module for you to play with. And also we have done this conceptual uh, modularized model, okay, and compare this one with the object-oriented programming. So I think this may takeaway for this session. Okay, so any questions? If no, I think that's all for today. Okay, so I hope to see you tomorrow lah. So that I'll show you that how this queuing model is modularized in O2DES.NET.